I want to talk about a bunch of different ways to make a length 20 vector that goes 1, -1, 1, -1, and so on. So let me start with what I think is the easiest way. I'm going to start by just making a length 20 vector of all ones. So I'm going to do v equals ones. Okay, a common mistake that I make is to say ones 20, but that would give me a 20 by 20 matrix. Okay, that's not what I want. I want a vector. So I want a row vector, so this is like saying 1 row, 20 columns. Okay, that's what I wanted. Okay, there I can check, that looks good. So now I want to change the second, the fourth, the sixth. I want to change entries in that pattern to -1, and I can do that using indexing. So I'm going to say 2, 2, up to 20 equals -1. Okay, and that worked. Probably a more elegant way to do it is instead of writing 20 to write end, E-N-D. Okay, that's more flexible so that if I change the vector to something of a different length, this way we'll still change all of the even elements. So that's one way to make this vector. Let me show you another way to make the vector. And the key idea behind this other way is I want to try to think of some function that gives me a pattern of ones, -1. So 1, -1, 1, -1, like that. And one function that gives me that is, think about -1 to the 0, -1 to the 1, -1 to the 2, -1 to the 3. Okay, that goes back and forth between 1 when the exponent's even and -1 when the exponent's odd. Okay, so let me show you how to do that. Let me do it with a mistake first. I could say -1, and then I want to go from 0 up to 19. Okay, that'll give me total length 20. But I've made a mistake here. What mistake did I make? The mistake is that I was trying to raise a number to a vector. And I'm allowed to do that, but I have to explicitly specify that it's supposed to be element-wise power or element-wise exponentiation. And I do that by putting a dot before the caret symbol. Okay, so there, that worked. That gave me -1 to the 0, -1 to the 1, all the way up to -1 to the 19. The last way I want to show you to make this, it's using the indexing for arrays in kind of an interesting way. So let me show you this. Let me make v1. Okay, this is going to be a length 10 vector of all ones. Let me say v2. This is going to be a length 10 vector of all -1s. Okay, so I get that by first making a length 10 vector of all ones and then multiplying it by -1. I also could have subtracted 2 like this. That would have been another way to get it. And then I want to fuse these together. So let me say A for array equals v1, so all ones in the first row, then all -1s in the second row. So what does A look like? I can check it out by double-clicking over here. So it's this 2 by 10 matrix, all ones in the first row, all -1s in the second row. And if you think back to how I said that indexing works, if I say something like A of 7, what's that? Well, it's like 1, 2, 3, 4, 5, 6, 7. So here's a cool way to change a matrix into a vector. I can just do A from 1 to the end. And so what did that do? Let me bring A back up again. So that gave me 1, 2, 3, 4, like that, all the way up to 19, 20. And it just put them in that order into a vector. So for example, if I were to do A of 3, 4, 5, 6. So what did that give me? That gave me the vector Here's 3, here's 4, here's 5, here's 6. So that's why it looks like 1, -1, 1, -1. Okay, so just to convince you that's really what it's doing, say I made these all equal to 15. Okay, then it changed the 3rd, 4th, 5th, and 6th into 15. Okay, but the one up before, so let me just remind you how we did it. We put V1 in the first row, V2 in the second row, and remember the rows get separated by a semicolon. And then I did A from 1 to the end. And that gave me this length 20 vector that I want.